All right, let's go ahead and look at example 4. We're going to look at more properties of integration. Consider an even function, f of x dx. You're integrating from 0 to 3, and they're telling you that's equal to 8. And they want you to find what is the integral from -3 to 3 of f of x dx. Well, if we were to, again, graph an even function, we know it's going to be symmetric about the y-axis, right? It's going to be symmetric about the y-axis. So we're going to use this property. Well, they tell us from 0 to 3, the area under the curve, right, is going to be equal to 8. Well, if this is symmetric about the y-axis, then we should also say the area under the curve from 0 to -3 or from -3 to 0 is also going to be 8. So the idea here is that you use your symmetry to make to solve this or to make this equal, right? So don't forget that if they give you the actual function and you know it's an even function, use those properties. And we get 16. Okay, for odd functions, what do we have for odd functions? What if I was to draw an odd function? They don't tell us what it is, but if I was to draw an odd function, the most basic odd function I could think of is the cubic. Okay, and again, let's just say this is 3, right? And this is 3, -3. So we're going to see that these areas should be equal to each other, but the biggest thing to consider is that this one's positive and this area is going to be negative. So this is just going to be the same but opposite signs, and we're going to get 0 because it's going to be the addition of both of those. All right, so that's another little trick. That's another way to think about when you are integrating an even or odd function, and then from a negative value to a positive upper bound. All right, let's look at some actual functions here. They say sketch the region and define the definite interval. So okay, I start off, I have this function x plus 3. I know that's a linear function. My graph is going to look something like this, right? And they want us to go from 1 to 4. So from 1 to 4. And again, when you have these kind of functions, you want to look at the shape. These are going to be trapezoids. Okay, if I get this trapezoid and I flip it around, I see that I could get the area. Again, this is going to be my height. Okay, my height. And my first base is going to be here, right, which is now here. And then the second base would be this other height. So whatever this height is and whatever this height is. And we know that the area is of a trapezoid is 1/2 the height times b1 plus b2. So again, this is going to be b1 and this is going to be b2. After I rotate it, that's what we get. So what is b1? Well, this height should be 4 because if I plug in 1, this is going to be f of 1, right? That's going to be my first base. So that should be 4. And if I plug in f of 4, I should get 7. So I know this height should be 7. Okay, so there you go. I have the equation of the area of a trapezoid. Is going to be 1/2 the base. 1/2 the height. Again, this is my change from 1 to 4, so that's going to be 3. And then 4 plus 7. A little arithmetic, and we get 33 over 2. All right. And again, you could break it down. You could do it other ways, but the best way to think of a trapezoid, it's an inverted trapezoid. That's the best way I could think about it. All right, this function here, it's a little bit more complicated. You're like, wait, I'm not sure I recognize that. So I don't know if you will have time to think about it, right? Especially if you're on a timed test. But it's good to know what kind of function we're dealing with right here, right? Well, let's start off with the equation of a circle, all right? So that's already giving us an idea. If you see something like this, you're going to get a circle, a semicircle, or part of a circle. So how do I make the equation of a circle look like this? Well, if I subtract x squared to both sides, I get y squared is equal to r squared minus x squared, and we know r squared is the radius. And if you were to plug this in your calculator, you're going to have to take the square root of that, right? And normally you will have a plus or minus. So your function should look something like this, plus, and then minus the square root, okay? We have the plus side here. So if I was to graph this function, and again, I just need a little bit of space, so let me see if I could do it on this side. And we know this is 4 squared, so the radius, r squared is equal to 4. That means r is going to be equal to 2. And maybe I should have made that a little bigger, but you guys get the point, okay? You're going to get something like this. You're going to get the area, and this is just the area of a circle with radius 2. It might be hard to integrate, but using geometry, we see that it'll become a little bit easier. So what's the area of a circle? Pi r squared, right? And we know that r in this case is going to be 2, so it's just going to be 4 pi. But we don't have the full circle, we have half a circle, so we just divide by 2, and we know that area is equal to 2 pi. All right, pretty easy. And again, these might be hard to integrate algebraically. Like this is actually easier, but we will learn how to do this algebraically in case you forget some of these geometric properties. All right, what does this look like? Again, this is just going to be an absolute value function shifted up 3. And you're going to go from -2 to 4. Again, just be a little careful here because this one extends 4 units and this one extends 2. So you want to make sure you go ahead and try that. And just for the sake of time, and I also want you guys to try this on your own, that area should be equal to 28. And again, just be careful because, again, this one goes 0 to 4, and then this is a -2. So don't multiply this. This is more of a, you have two trapezoids. One's going to be a shorter height than the other one, right? Okay, this one, cubic function. It's not a cubic function, it's the square or the cube root. And it looks something like this. So whatever you get from here to here, you're going to get from there to there. And you know what's going to happen because it goes from -4 to 4. That's an odd function. So you guys should figure that out by now. Okay, this function here, again, it's just going to be a linear function, right? Something like that. Make sure your slope is 3, and then you go from what? From 1 to 4. Figure out the area. Make this into a trapezoid. Again, the area is going to be 1/2 the height, or the change in x, times your b1 plus your b2. So go ahead and try that one as well. And then this one, it's a little bit more complicated because you have the sum of two integrals. And you could look at this as the addition of 1 plus the square root of 4 minus x squared, right? But you could break this down as well. We know this is just going to be a rectangle. We know this is going to be a semicircle. And you could break this down as well. I'm going to leave that up to you guys. And just so you guys know, the total area for this one is going to be pi plus 1/2. All right. Good luck. Try those out. And don't forget to do the homework. I will be posting what problems you have to do for that later.